Hello, my name is Tulika and I'm a product manager with the Azure App Service team. I'm here to talk about the new sidecar feature that we announced at Microsoft Ignite 2024 and show you how you can use the feature to integrate AI capabilities into your Python application. To get started, you can create a Python application from the Azure portal. You can go to Create a Resource, and there you will see the option to create a web app. Hitting on the Create button over here will take you to the portal flow to create an application. There are two kinds of applications you can create. The first one is a code-based application. Here you give us the runtime stack that you want to use. As you can see, we have all the different supported versions of Python available. And you specify where your code resides. Your code could reside in GitHub, Azure DevOps, or you can choose to deploy your code using zip deploy. The other kind of app that you can create is a container-based application. Here, you give us the Docker image that you've created. So if you go to the Container tab, you can specify where your image resides. It could reside in Azure Container Registry, Docker Hub, or even on a private registry on-premise, and we can pull the image for you. There are certain properties that you specify for the image, like the registry, the image, the tag, and the port. You can also specify an optional startup command, which would be executed every time your application starts up. Moving on to the sidecar feature. Sidecar is an architectural pattern which allows you to add peripheral tasks for your application running in its own containers. These peripheral tasks for a web application could be things like observability, monitoring, caching, or even AI, as we will see very shortly. The fact that you can have these peripheral tasks as different containers makes that your application is easier to maintain and you can plug and play different components. Let's go to the first example that I have set up for you. I can browse this application and it's a simple chat application. So I can ask it a question and hit send. It'll start generating the response. Now, a couple of things that I want to point out about this application. Firstly, I am using a container-based application here. And I have got a front end, which is the UI that you see over here, which has a text box and a button. I have the backend application, which is a sidecar. This sidecar is loading a small language model or SLM. The specific model that I'm using is a Phi 3 CPU-based model. Small language models are a great alternative, especially when you want to run your application on CPU-based workloads. So here, as I mentioned, that I have my web application, it is running as a container-based app. Sidecar works for both code and container apps. So here I'm showing you a container app. To add a sidecar, you go to the Deployment Center and you will see that there is a new Containers tab which is available for you. You will already see the main container added. The main container is the main application, which is the UI for your application in my case. And you can add one or more sidecars. I've already added my Phi 3 SLM as a sidecar. So to point out certain properties of this sidecar, the first is the name. It could be anything. The type is sidecar. Now, what this really means is that no HTTP request can directly come from the outside world to the sidecar. Only the main container can talk to the sidecar. You can specify the image source, which could be Azure Container Registry as it is here, or it could be Docker Hub or a private registry. You can specify authentication options. I'm using admin credentials, but you can set it up with managed identity as well. And you specify properties of the image like the registry, the name, the image tag, the port, and even a startup command if you needed to. Now that sets up your application. Let's go ahead and look at the code of the application. As I mentioned earlier, I am using Phi 3 as my model. I'm using the CPU-based model, which is an offline model. So I'm actually referring to the model directly from the file system. That's what you see over here. I create a tokenizer for the model just to ensure that I can pass in the tokens and get a response back. My API has a single method called predict, which accepts a single input, which is the text that we put in the text box. So in this case, the question, what is Azure App Service? I've created a chat template. In my case, the chat template has nothing very specific into it. I'm just passing in the input, which is coming from whatever the function is being called with. I've set up some parameters for the model, for example, the max length for it, some search options, and so on. Most of the work over here is actually happening in this section where I'm generating the response to the question that I've asked. The response is being generated one token at a time. And this token is yielded back to the client so that you get a streaming response. When you start creating AI applications, you will often notice that it takes some time for the full response to be generated, depending on how large the response is. And therefore, we always recommend that you implement a streaming response. So that's what we're doing here. Now, since this is a sidecar, I'm running it as a container. I have a Docker file over here which builds the container. The Docker file is fairly simple. I'm using the Python 3.9 image. Now, since I'm using the offline model, I have to copy the model into my Docker image. And this is the line that is doing that. It's copying it from my local file system into the Docker image. I'm copying the API file that I created, and I'm exposing a single port called 8000. Once I have the image, I can use any kind of Docker tools to build the container and push it into my container registry. Now let's go ahead and look at the front-end application. The front-end application is a simple fast API application. The important thing over here is the API URL. This is the URL of the backend, if you will. In my case, it is the sidecar. The first thing to notice here is that I'm calling the sidecar API on localhost. This is because the main container and the sidecar share the same network namespace. I'm using port 8000. That's the port I had exposed earlier in my Docker file. And I'm using the predict method, which is the single method that I exposed in my API. I have a method called send message, which is going ahead and making a post call to the backend API and returning a response. This response is then being shown onto the browser window one chunk at a time. So you're getting the streaming response. Now, since I created a container-based application, I also have a Docker file over here. This is just a sample Docker file that you would use for any Python application. It is building from Python 3.9, setting the environment variable for Flask, and exposing a port for it. And that makes you set up a simple chat application in Python using the sidecar pattern. Now let's go ahead and move to another example, which is slightly more involved. So here I have another application which is set up. Let's first go ahead and browse this application. Now I'm trying to create a fashion store assistant. I have some products in my database. As you can see, this is the list of products. And I want to ask questions about these list of products. So I can choose anything from here and now ask it a question. Now, my database contains two things. One is the name of the product. The other is the description for the product. But I'm going to ask it a question which is not in the database. For example, I'm asking it, how can I wear the blazer? In situations like this, generative AI really shines. So even though this information is not in the database, it can take the context of the product and generate a unique response for the question that I asked. So now it is giving me options on how do I pair the blazer and giving me a list of options over here. Let's go ahead and look at some of the properties of this application. The first property that I want to point out over here is that this is a code-based application. Now, you might be surprised to see that the runtime stack over here is .NET Core. That's because I again have the same model that I mentioned earlier. I have a front end and a back end, but in this case, my front end is .NET Core. In fact, it's a Blazor application. I could have used Flask application, but I just wanted to show you the cool thing about sidecars, where you can run a front end and a back end using different language frameworks and stacks. So my back end is still Python, but my front end is .NET. Now for a code-based app, to add a sidecar, you do exactly the same thing. You go to the deployment center, and you will see the new containers tab where you can add one or more sidecars. Now, since this is a code-based app, you don't see the main container because you've given us the code, but you do see the ability to add sidecars. I've already added the Phi3 sidecar over here. So you see the name and the image source. Here I've pushed the image into Microsoft Container Registry, which is the public registry. So you can see it over here, and you specify things like the registry URL, the name, and the tag, and so on. Now let's go ahead and start looking at the code for this application. Just like before, I am using the CPU-based model and loading it from the file system. That's the line over here. I'm creating the tokenizer again, just as before. I have a single method called predict, which is accepting the input data. But here I'm creating a chat template, which is slightly more involved. I'm specifying what the system should do. So my system message is that it should give me concise information. I want to make sure that it keeps the responses brief and only focuses on key points. Of course, you can change the system message to be anything that you want your assistant to be like. The second change that I have over here is when I'm setting the input prompt, I'm taking the user message, that's the question you asked, but appending it with the product name and description. So this gives the context for the response. In essence, I'm making my model work as a chat completion. So I'm essentially creating a chat completion API over here. We do the same stuff that we have the tokenizer encoding the prompt. I have reduced the max length to be 300 over here. And then all the earlier stuff that I'd mentioned, that we are generating the response one token at a time. As soon as we get a token, we are yielding it back to the client. Again, I have the Docker file. Again, I copied the Docker file I'd used earlier and just over here. So you see the copy statement, which is copying the model from the file system. I'm copying the API file and exposing the port. Now let's go to the front-end application, which in this case is my Blazor.NET application. The first thing is I specify the URL I'm going to talk to the backend. In this case, it is localhost, again, because the main container and the sidecar share the same network namespace. I'm using the port 8000. That's the port we had exposed. The work happens in my home.razor. Here, I'm making a HTTP post request to the API that I specified earlier, and then using StreamReader to stream the response back to the browser window. The thing that I want to point out over here is, as far as the front-end application is concerned, whether this is the .NET application or the earlier Python Flask application, it has no AI components. So all it's doing is a HTTP post method. Essentially, it means that you can switch out your back-end model to something else, or you can update the model, and your front-end is going to remain exactly the same. And that's one of the benefits of using sidecars, that now you can go ahead and update different parts of your application without affecting other parts of your application. If you want to try out this, we have a couple of blogs which has the code repo as well. So this is the first blog which shows you the first chat application that I showed you with the Flask front end and the back end using the SLM. I have another blog which is slightly more involved. This tries to implement a local RAG by using an in-memory vector database. So whenever you ask it a question, it will first search it in the vector database, and depending on the response, it will generate a response for you. We are quite excited that you should try out this feature. Let us know how it goes. We are always open to feedback and improving the product based on your feedback. This brings me to the end of my talk. Thank you for listening to me.